All right, thanks for everyone for coming. Today we're going to be talking about augmented reality with ARKit. So I'll just give you an introduction to who I am. I'm Michael Ridland. I run a mobile development company in Sydney and Melbourne. Primarily known for doing Xamarin work, but we do a bit of native as well. So demos today will be in Xcode and they'll also be in Xamarin. So traditionally, augmented reality has been kind of geeky, nerdy. It hasn't sort of hit anything mainstream yet, which is quite interesting because I mean, we had the Google Glass come out and that sort of people thought that was kind of cool, but it was still very, very nerdy. But in my sort of research and what I've been finding out with ARKit and what Apple's actually doing, this is set to change. It's set to change at some point. We don't know when it's changing, but after looking into the APIs and seeing how much investment Apple's actually making into ARKit, ARKit is not just designed for the phone. I mean, obviously we're using it on the phone now because that's the device that we have, but there is something that Apple are working on. We don't actually know what it is, but that's probably going to be something, some sort of glasses. So here's a little thing. What's actually going to happen, I see, anyway, AR's been very nerdy for a long, long time, but I can see that like we had the HoloLens, we had Pokemon Go, that kind of like took it to the mainstream, but it's still not very mainstream. But what's going to happen is somebody's going to release a product, and that product's going to come out, and overnight it's going to be everywhere. This is pretty similar to the way the smartphone was never there. It was a bit nerdy. You have some nerds had their the Windows phones, but as soon as it came out to a consumer launch, then it was instantly everywhere. So I think that pretty much the same thing is going to happen with augmented reality. So just to give you a bit of a sort of taste of what it could be like, this video is actually built with ARKit, and this is a Tesla 3. Oh no, sorry. Oh yeah, so this Apple have a bunch of patents out on augmented reality stuff, and they're buying a bunch of different startups. Some people say that the Apple's augmented reality glasses are probably 2 years away, but nobody actually knows. It'll be pretty interesting to see when they come out. So yeah, this video is built with ARKit, and it's a pretty interesting video to give you an understanding of what it's going to be like. So this is a Tesla 3. You can go through and you can pick all your different colors, pick the wheels that you want, and you can actually drive it in the real world. Yeah, so one of the really interesting things when you start playing with ARKit is it's kind of like a glimpse into the future, which is really cool. So there's other websites that you can go to. There's AR Prototype. So this is a good page to sort of understand what the future is going to look like with augmented reality. So I really like this one. So this is actually built with ARKit too. Obviously this is through a phone at the moment, but the experience would actually be really good if it was through some sort of glasses. So that's a real working, well not app, but it's a real working demo. So there's other things you can do. So that's sort of augmenting the real world. You can see here, you can bring things to life. So you can actually do this with ARKit already at the moment, with ARKit 2, iOS 12. So what this is actually doing, we'll go into, but basically it's doing a thing called image tracking. So ARKit can actually pick up your the different images that you've got, and it can actually match them, and you can augment those images, and it'll track those images for you. ARKit does all the hard work for you. So it's going to be really interesting to see the things that people start making or are already making. There's a website called madewitharkit.com, so you can check that out as well. So why do we need ARKit? ARKit is there because doing augmented reality is really hard. So there's lots of mathematical calculations that you need to do. It's really hard to do these calculations without killing the user's battery and without or having a high frame rate. So Apple have gone in, they've done all that hard work for you. So it's really good to see. Once you see how easy it is, you really see that they've done such a good job with it. So we're just going to go through how ARKit works. So on your device here, obviously like something like the HoloLens that has lots of sensors. Your phone doesn't have any sensors that are specifically for augmented reality, but it does have a camera and it has an accelerometer, and it has a few different sensors that you can actually use to actually do the mathematical calculations that you need to build a real world. So basically when you're creating an AR application, so you've got the audio visual, or the AV foundation, so that's the video going into ARKit, and you've also got the motion going into ARKit. And you can see here, ARKit is primarily just for the processing and all the mathematical calculations, whereas rendering, you can see here, iOS already has the SceneKit and the SpriteKit. Most of the time when you're doing augmented reality apps, a lot of people are going to be using different engines. So you can use ARKit with other engines, say like Unreal or Unity. So just some of the features that ARKit have. Orientation tracking. So orientation tracking is basically you're standing still. It's not really building up a 3D world. So this is where you've got your 360 photos and your 360 video. So you can stand still and you can hold it up and move around. It's kind of basic. There's not much freedom in it really. World tracking. So this is where ARKit is going in and it's creating a 3D model of the world. So it's doing all the hard work for you there. So this is where you can actually move around things. And then also plane detection. So as you're moving around, you want to be able to see the planes, and you want to be able to place items and be able to augment. So the plane detection is a really important thing to be able to use augmented reality. So some new features in ARKit 2, the ability to save and load maps. So with ARKit 2, we can actually have multiple multiplayer games, so people actually sharing the sharing experience, which we'll see, and image tracking. So a lot of those demos that you saw were just basic image tracking, and it's actually only about 10 lines of code to get that working really. And also there's 3D object detection. So an object like this, you should be able to scan it in and then later on detect it, which we'll do. So you can see here, ARKit is, as you're moving it around, it's detecting the planes, it's getting all these points on the plane. It uses all the different textures on the planes. So the more if you're in a white room, then it's not going to be able to pick things up very easily. But if you're in a really textured room or something like this is actually a good place to do a demo. And as we saw, orientation tracking is basically just your orientation in the world. So there's no 3D movement in that case. So ARKit uses the motion sensor. This is called Inertial Odometry. So as the motions of the device are going through, ARKit is doing all the calculations on that. It also does visual odometry, which is basically taking images that are coming from the camera. And it does this because the processing on images is a lot slower than it can be on the raw data that comes from the other sensors. You can see that it's actually skipping frames. So what ARKit does is it combines the video and it combines the motion. So we've got the motion and we've got the CV data. So it's actually doing a combination of both of them. So to create the 3D world, ARKit basically will be doing triangulation. So as you move the device around, it can see where you were, where you've moved, and it can calculate the triangles in between that. So basically, the same as you see, the same as you have two eyes and you can do the calculations and you can see 3D, ARKit is very similar. As you start moving your phone around and you start getting all your planes, then ARKit will create anchor points for you, and based on those anchor points then you can place things in the world. So you can see here we've got an AR. Well, this is basically how AR is working. You've got all your AR session and your AR frames here. Whatever engine you're using, you're getting your light estimation, adding that to a camera. So you've got your 3D, your 3D scene here, and then you've got your image, and that's overlaid on top of the image. So just a few notes on world tracking. So sensor data can have quality issues. So imagine you're in a moving bus. If you're in a moving bus, the data that it's getting from the sensors is going to be different to the data that it's getting from the images. So it's not possible that it's able to create a world scene for you. So textured environments work best. So if you're in a completely white room, it's really not going to work that well. So the health of basically the health of the environment tracking can be monitored, and you'll get that feedback back from ARKit. And it's important to guide the user on what they need to do. And yeah, you need to notify the user of what they need to be doing. So we can see the different tracking states. Let's just have a look here. Just going to do a demo. In iOS 12, if you haven't updated yet, there's an app called Measure, and that's using ARKit too. So let's just have a look at this. So I'm just going to open up the Measure app. So what you'll see here is the Measure app's actually guiding me on what I need to do. So it's saying I need to move it around. Now if I start doing it too fast, so it'll actually say you're moving it too fast, or if I'm blocking out the camera and moving it, then it can't do the tracking. So let's just have a look. So this Measure app's actually very, very accurate. Let's see if I can get a surface. So just say I wanted to measure something. I've actually been using this a lot. It's really cool to be able to just measure something without having a tape measure. It's actually really useful. So you can see here that you need to give the user the data on the tracking. So I'm just going to go through how you would build your first AR experience. So you need an AR session. And to start the session, you need to provide a configuration. The configuration is basically what we saw before. Do you want the world tracking? Do you want the image tracking? The different type of tracking configuration. You then call the run method on that session. And then the data will start, well, the video data and the motion data will go into the AR session. And then from there, the frames will come through. So I'll just give it a little bit of a demo. So I'm just going to give you a demo of what this app is actually doing. Okay, so it's actually giving me the feedback that I need to move the device around. And basically what I'm doing is I'm detecting, or as the ARKit is doing the detection of planes, then I'm just actually drawing on top of that. So you can see as I'm moving around. So it can do vertical and horizontal tracking. So you can put things on walls. So we can get the floor there, and hopefully we can get the table separately. Yeah, so it's got the it's picked up the table is separate to the floor, which is really good. So I'll just take us through the code that we need to do that. It's surprisingly easy. So this is just a standard iOS application. Most of the code is just in this single view controller that we have here. So basically, as the view's appearing, or as the app's appearing, we check that we have the world tracking enabled, show an error message to the user if we don't. And then here's where we're creating the configuration. So we've got AR world tracking, so that's basically creating a 3D model of the world. If I change this, so you see here I can have the world tracking, image tracking, face tracking, so these are all the different type of tracking we want. In this case, we're just going to do the world tracking. We want to say that we're detecting the vertical and horizontal planes, and then we're actually just running that. So what we're also doing is there's events. So as we have the session and those events where we're guiding the user, we're just handling those events. So this is where we've got a delegate which is handling those events. So what actually happens is, as you're moving around, when a plane is detected, then a AR plane anchor will be added into the system. So here we've got our render function, and then on the did add node event, we check that the anchor that we've got is an AR plane anchor, so we know it's a plane that we've discovered. I mean, the other anchors that you could do would be an image anchor or an object anchor. They're the primary ones that you would do. And basically this scene node is basically what we saw with the red image that was being drawn on the planes. And then we add that. So this is when it's initially added. If we go a little bit further down, then you can see here that when the node's updated, we check that we've got the correct node that we want to update. And then you can see here, we're just basically, as it changes and as it grows, then we're actually updating the geometry and changing the size of that UI. So I was playing around with different colors here as well. So maybe we could change this color to change the color around and run it again. So you can see down here, we're actually doing all these handling of the events that are coming out of ARKit. So when an anchor is added, we're just updating the info label when the anchors are removed. But most importantly, what we're doing down here is we're actually detecting the tracking state and we're guiding the user. So initially, when we haven't found any anchors, it's saying that we need to move the device around until we find the surfaces. If the tracking is not available, then it says unavailable. And then if there's, say, excessive motion, then we're actually guiding the user to say, look, you're moving the device too fast. And then when there's limited tracking, say the images or low light or something like that, we're giving that feedback to the user. So that's a basic introduction. So image tracking is a lot of the demos that we've already seen that was using image tracking, but I can just give you another sort of demo of this. So yeah, it's, doing that is actually quite easy. It's actually surprising how easy it is to do that. So let me just open up my demo that I've got. And what I'm going to do is I'm going to run the demo first so you can see what we're going to be playing around with. So here, got my device, I've got my new business card that I'm going to be using. And if I link it up like that, and if I put it down on the surface, a little bit of reflection there. This worked every time I did it, like 30 times, 40 times. For some reason it's not working. So with different images, some images work better than others. So these images, I mean, even though they have been working for me, they're probably not the most ideal images. So you can actually see here, we've got an error message saying that these images, they don't have enough different textures in them, and then when they're converted to black and white, it's really hard for ARKit to pick them up. But basically what you need to do with the image tracking, well, all you need to do is have an image and you need to set the physical size of it. So you can see here that I've got a business card and I've actually set up in the top right, set it to 8 centimeters. So it actually has to have a real world size. So you need to know the size of it. So I've done that for both of these. What I've got over here is not actually an image, it's a 3D object that I've scanned, but that's not part of this demo. So I'm just going to take us through how to set all this up. So it's very similar to the last project, it's just a view controller. In this case I've created some videos, so I just picked those videos up from the local system. If we go down, you can see I'm repeating the videos, I'm going through and doing a few different things. And so you can see here where we set up the scene and we start the image tracking. So basically here we've got AR reference images and we're picking them up. So basically this call here is picking up those images that were in this AR resources folder. So now we have a list of the images we want to track. And the configuration that we're using this time is the image tracking configuration. So image tracking configuration and then tracking images. So as we go down, all we need to do is pass that configuration into the ARKit session and into the run method. So you saw that there was some text on the screen. So with that text, this is just a basic method to add text onto the screen. And basically that just returns a node with the UI elements that we need. So what actually happens as ARKit's moving around, when it detects an image, then it'll call this render function and it'll give you an anchor for the different types of objects. So if it's an image or if it's an object. So you can see here, if it's an AR object, in this case we're not doing the AR object, it's just an image. But if you move a little bit further down, if it's an AR image anchor, then we're picking that up and saying, okay, so it's an image anchor, this is what we need to do. As we go a little bit further down, I'm actually just checking the name of it. So if we look in here, business card is one side and the other side is the business card, the back of it. So I've just got like a little if statement there. So to play things on the screen, basically we create a plane for that. And then we've actually added, as the material and the contents, we've added a video. And that's the video that you see playing. Then we set up the node, and then we add that node to the parent node, which is the image that's being tracked. So you can see here, this is one of the videos. There was 2 videos playing, so there's another video. It's pretty much exactly the same. In this case, we're creating a text node, and we're switching the position. So this is just a little helper function to be able to move things around in relation to the image. So what we actually do is if it's the other side, which is the animation, then we're doing almost exactly the same thing, but this time we're actually using a 3D model. So if you see in here, I've got a 3D model, and there's actually two 3D models. Hopefully I can get the monkey working. And that's actually all you need to do. There's a few bits of extra code for like getting the events on the sessions, but apart from that, that's kind of all the application does. Or that's all you need to do to build that application. So one of the other things that you can do in ARKit too is you can actually see real-world reflections. So I'll just give you a little bit of a demo of this. So you can actually see there, it's actually taken what it sees in the world and it's using that as a reflection on a 3D object that I've added. So this can be really useful if you're, say, building like a 3D game and you want to be able to have realistic reflections on anything really. And as I move it around, I mean, the more time you spend tracking, the better the 3D reflections get. So we can go through this code and have a look and see what it's doing. I mean, it's pretty much exactly the same. We've got a view controller here. We're setting up a scene and basically creating a sphere. And then what we're actually doing is setting the lighting model to physically based. So that means that it's actually going to be doing the reflection for us. And then we saw a little bit of animation. So in here, this is where it's doing that animation back and forth. So if you were using like a different 3D engine, all this stuff as far as like animations and these materials, you wouldn't use these APIs. You would use the APIs of your 3D engine. But you can see here, doing AR world tracking configuration again, and then you can see here we're actually setting the environment texturing to automatic. So I can just give you a demo of what it will be like without that. Pretty boring without the reflections. So one of the other things that came out recently in ARKit 2, which is like a really big thing, is shared experiences. So basically you can do two things with the map, like saving and loading. You can either have like a multiplayer game, or you can save a map and come back to it later. So just say you're playing a game and you've placed some objects in a certain place. Then you leave and come back, and you want to be able to like reload that map. So you can see here, this is an example of a multiplayer game that Apple created called Swiftshot. So basically up to 4 players can play, or up to 8 players can play this. And basically it's like a virtual 3D environment which you play other people. The idea is to knock other people's slingshots down. So the code for this is actually like open source. So if you want to like download this code, all you need is Xcode. So you can download that code and you can start using that game straight away. So basically, device A would do the initial world map, so it would start moving around, create that world map, and then it would share it with the other devices. So this is what like a world map would look like, a bit of a visualization of it. So that's what we're saving that, and we're sending that over to the other device. To do that, we can call on the session. So that's the AR session. We call get the current world map. And then once we've got that world map, then we're archiving that data into a data set that we can send across the network. And then on the other side, once we've received the world map, then we're setting up our world tracking configuration with our initial world map, and then we're running that AR session. So 3D object scanning. So the example that Apple used with 3D object scanning was, say, a museum. So you can come in and you can scan the objects, and then when someone comes to the museum, if you hold up to that 3D object, then that object can come to life. It can give you the information that you need. So I might just give you a bit of a demo of 3D object scanning. So when you're actually scanning, that's not really for an end user. Scanning is for you to be able to scan the object so you can read it later. So I'm just going to... So I'm just going to go through, scan a new object. So I want to scan this monkey in. Let's go like that maybe. This is really good light in this room. So I'm just going to start the scan going through. So you can see all the dot points on it. Well, I've lost the tracking a little bit there. There we go, it's brought it back. All right, so now I've scanned it in. Now I want to be able to detect that object. So you can see it's detected it. I think from the back it's going to be a bit hard for it to detect it, but let's see if I can do it. No, I didn't do a good job of scanning the back of it. All right, so that's a 3D object. So that's actually going in and scanning it in. It's also detecting it. So I do have a sample of detecting an object. So let's see if we can get this one working. So this is in the same demo as the image tracking. So you saw before I had this like monkey that I'd previously scanned. So I'm going to try and detect this 3D object. When I did this scanning, I didn't have the same sort of light as that, so it wasn't, the scan isn't a great scan, so I don't actually know if this is going to work, but we can try it anyway. So I'm just going back up to where I set up everything. So you can see here I've already set up the code for that. So basically that same AR resources folder, and this time I'm getting reference objects out. So you can see we have, at the top we have the tracking images, and then down underneath we have the reference objects. So what I'm going to do, when you're doing image tracking, you can't actually do object detection as well. So I'm just going to change this to AR world tracking, and then put in the objects as well. So you can actually have images, so you can do images and objects in world tracking. a look. No. The problem that I found with this is because it's a soft toy, it changes shape. So all the points that it's collected when it's done the scan have actually changed. So it doesn't really work with soft toys. It's a good note. Good note. So ARKit, with all the native APIs that you have for like 3D rendering in iOS, is okay, but most people don't actually do that. Most people are using like a different engine, like Unity, for example. There's actually a thing called Sharp, which is a 3D engine, and that's a built-in Xamarin. So this is a Xamarin demo. What I'm going to do is I'm just going to show you this. So basically, you can use ARKit with anything you want, really, as long as that framework can take in the data and you can build that 3D world. Because basically, ARKit's just providing you data of a 3D world, and you can put whatever you want in that 3D world. So as we're going through this application, you can see it's an application. So that's where the main application happens, but we also have an AR session delegate. So as we go through here, you can see here we're creating the AR scene. Really, we're just creating a scene. It doesn't need to be called AR scene, because this is actually a 3D scene that can be put anywhere. And this is the Sharp API. So you see here it's putting together all the scenes that we need. Adding a camera, adding lighting, showing it like a viewport. So this will be familiar down here. We can see here we're creating an AR session, and we're also creating it with the world tracking configuration. And then in this case, we just have a horizontal plane detection. So what is actually happening here is we've got the AR session running, we've also got the 3D engine, but we need to connect them somehow. So basically, to do that, we created our own session delegate. So basically all the events that are coming out of ARKit, we're taking in all those events, and we're using those events to understand the world and discover where we want to put things. So you can see here, as a frames are updated in the AR frames, you can see here that it goes back to and it's actually processing those frames for you. We can also say, see as anchors are added, then we're taking those anchors and we're providing it to the 3D engine. So I'm just going to go through and just going to run that app, just give us a bit of a demo. can't see it. What's going on there? Work. There we go. You can see that a lot better now. So I'm just going to move these monsters around. So there's actually 2 demos. So obviously, I mean, if you look at the code differences between the built-in stuff, there's a lot more code to get this working, but it is like a 3D engine, so there's going to be a lot more code. So what I want to actually try and do, I couldn't get this working earlier today, but I want to try and scan a 3D object and then show that other demo. So now that I've got some better light, let's see if we can scan that object. Let's try and rebuild this solution. It was working before, but it stopped working earlier today. The perfect data for it to stop working. It started working, okay. Now let's just try this. Let's start scanning it. Get the right size for it. I'm not even going to bother doing the back of it, so let's just finish that off. What I'm actually going to do is see if it's working, so it's detecting it. So that's great. So now I'm just going to share that with myself. So now I'm sharing that with myself. Hopefully it's not going to take too long. All right. It's getting there. Okay. So let's just download that. So now that I've downloaded it, I'm going to import it into my image tracker, and hopefully we can pick up this. So I'm just going to look in my asset catalog here. I'm going to delete this old one. Alright, so there's the monkey that I just scanned, so hopefully it hasn't changed too much. Fingers crossed, let's see what's going to happen. So I'm just going to go back in and double check we've got everything. So we're detecting images and objects. Don't really need to do any of the image detection, so let's just ignore that. So it did actually detect it. Let me just put in a debug point here. Let's see what happens. Let's restart it. Because it already detected it, so I just want to see what's happening here. Okay, so I can see that it's detecting the image, but where I'm actually pasting the image is not in the right spot for some reason. Let's just try and play around with these figures. It's going to turn off the animations that I had for it. Let's see if this gives us a better result. Let's make it bigger. Yeah, not working. Demo fail. Oh well. But what I can do is I can actually take this animation that I'm doing and I'll just display it on the image tracking. So let me just move this code here. So this is the animation. This is the other 3D model that I was playing around with. I'm just going to put that in the image detection and see how well that's going to work. All right, let's give that one a go. So I want to show you the animation working in this case. For some reason, this one is not working. I think I must have bent it or something, or the reflection's too much because it's got the shiny pin on it, which is quite interesting. Because it was actually working earlier today. So this object is going to give us a better reference. I know what I did wrong. It's going to change this back to image tracking. Make it a bit smaller, I think it's too big. I'll make the animation run a little bit slower as well. Alright, I think this is actually going to work, this demo. So it's all a little bit of fun. So those 3D models, you can download them off the net. You can get a lot of them for free. It's pretty easy stuff. So just go like a little bit of a recap. Some of the things that are available in ARKit. We've got our orientation tracking, our world tracking, the plane detection, as we saw, saving and loading maps, image tracking, and the object detection. So I think all in all, ARKit's pretty fun to play around with. It's not too hard to get a demo up and running. Yeah, and recommend giving it a try. Any questions? Yes, yeah, so that's what I did. So the scan 3D model here, this monkey AR object. So that's actually the 3D model that's been scanned. There's no way to visualize it, no, because it's not what you've scanned is not a 3D model. It's actually just the data points. Yeah, yeah. So you would be able to visualize that. What you can visualize, if we go in here, it does take a little bit of an image of it, but that's all you can do at the moment. Any other questions?
If you had any predictions of what might be the killer AR applications when they eventuate, or even some more obscure things that you hadn't even thought of?
Like I think that like just going out to like a bus stop and having like one of the items on the bus stop, having that like a live view of it. But as far as like killer applications, I think just like the way that it can integrate like just with everyday things. So like I imagine like having say like a watch and like glasses and not even having a phone, not even needing the phone. So for any little visualizations that you want to see, like the weather or something simple like that, I think that's what's actually going to be the real changer. I don't think it's some like big crazy thing that's going to be that everybody's going to have. It's just those like simple day-to-day things that can really, yeah, yeah, yeah. So yeah, just like I really like how like these mobile devices, it's the simple things that like really change the way that you sort of live your day. So I think that that's going to be the same. Any other questions? All good. Thank you, everyone.